Welcome to today's session on inequalities on a number line. So number lines, I'm sure that you're aware of them. It's just literally a line with numbers increasing from left to right. But we can actually use these to represent or show inequalities. But there's a couple of circles and arrows that we need to be made aware of. So this is the first one. We've got an open with an arrow going to the left. So let's say that this is the value of x here. So this means that all of our values less than this value would satisfy our inequality. As opposed to an open circle with the arrow going to the right, which means that all the values greater than this number would satisfy our inequality. We can use filled in circles. Anytime that we use a filled in circle, this will be for our inclusive inequalities. So here, our value of x here could also be equal to as well as being less than this value, as opposed to our filled in circle going to the right, which means the opposite. So this value here could be part of the solution as well as all the numbers greater than. And we could have something like this where we haven't got an arrow. We've got a circle connected by a line to another circle. This means simply that all of our values along this line, all of our values, including this one, could be part of our solution, but not this value. So shown by the inequality that A is less than x, but x could also be less than or equal to B. We'll see this in actual examples, just so we can get a proper idea on how it would look. So we've got x being less than or equal to 1. Now we can represent this on our number line. First of all, first thing that we want to do is identify when number 1 is on our number line and draw a circle. Now, if our sign is a strict inequality, so a less than or greater than, we are going to draw an open circle. If it's an inclusive inequality, less than or equal to, greater than or equal to, we are going to put in a filled in circle. And then x is less than or equal to 1, so we're going to draw an arrow going to the left hand side of our circle, because all values going down to the left are all less than 1. Just showing another example here of -2 being less than x, but x is also less than or equal to 2. So again, we're going to identify where -2 is, identify where 2 is. We're going to use an open circle at -2 because of our strict inequality. And we're going to use a filled in circle because of our inclusive inequality. And we're going to draw a line going through, which tells us that all the values along this line, including 2, could be part of our solution. And we could get a question asking us to list the whole numbers or integers which satisfy this inequality. So we wouldn't include -2 because x is greater than -2. So we'd have -1, 0, 1, and we'd have 2 because x could be less than or equal to 2. We could actually represent simultaneous inequalities using a number line also. So here I've got x is less than or equal to 1 and x is less than 4. So I'm going to put both of these onto my number line. Here's my x is less than or equal to 1. Again, identify 1. It's going to be a filled in circle because of my inclusive inequality. And now I'm going to do my x is less than 4. So identify 4, and it's going to be an open circle because of my strict inequality. Now my solution for this is x is less than or equal to 1, because at this point here it actually satisfies both of our inequalities. Our line going across here and our filled in circle is actually part of both solutions. Everything from here to here will not be part of the solution because we're looking for the values that satisfy both of our inequalities. Hence why it's simultaneous. We're looking to solve them both at the exact same time. And just another example. So x is less than or equal to 1. And minus 2 is less than x, but less than or equal to 2. So our solution here is minus 2, but x is going to be greater than this because of our open circle, and we're going to come up to x being less than or equal to 1 as part of our solution. And again, we could be asked to maybe list the values that satisfy this. Here we've got two inequalities that are shown on the number line. So x is less than 2, find 2, draw a line to the left because x is less than 2. X being greater than or equal to 3, filled in a circle because of my inclusive inequality, and a line going to the right. But as you can see, they do not overlap. There's no area which is actually corresponding similar to both of our inequalities. Because they don't overlap, there is no solution to this. Thank you very much for watching.